Hello, Professor. I apologize for this delay. It's been a crazy week, and I have frankly given up on trying to schedule a meeting so we can all record. So I'm just going to do it, so we don't slack on time. Um, but everything is going according to plan. I will just show you in depth what we've been doing. So. On this sheet, we begun and we're almost done with our literature review. Here we have excuse me, one sentence summaries, as well as references and all that good stuff. And in another document, we're slowly compiling it to fit how the learnings we got from these into fit within our project and what it tells us. It said in short, in a quick summary, what all of these, most of these primarily tell us is that we're opening up with the idea that while our system, which is right here, is useful, our project is more descriptive, is more informative, due to the fact that there's various ways of assessing risk. And volatility, even though it's been for 50 plus years thought of as the most as a really good metric for describing risk in a portfolio, it more recently people are starting to agree that it's not, but in general it is, but if we want to be very scientific about it, we want to look at the basics of companies and their earnings, their equity ratios, all that good stuff. Anyhow, let me just dive into the code so we can be a little bit more technical for longer. So, okay, we started out with wanting to have comparisons between different stock baskets of 20 stocks, but we decided to only go with 15 stocks, just for the purpose of simplicity. 20 stocks would have taken quite a bit of power, and also would have made us have very cluttered visualizations. 15 is more than plenty, but vast majority of Americans own 15 stocks, 15 to 20 stocks, so we went on the lower side. So the way we did it is each of us takes two groups of stocks. I'm particularly taking value and growth stocks, and we were essentially rerunning this notebook with the tickers that we're getting, with the ticker string lists that we're getting. We load the data into here, and we continue on. So yeah, once we identified what we want, we use this set portfolio and we analyze it. So here we created some first descriptive views. This is just an overall histogram of adjusted closing prices. Box plots of adjusted closing prices. We can see which stocks are expensive, which aren't. And also adjusted closing prices. This also includes, of course, the stock splits and all that. Here we have a correlation matrix of adjusted stock prices to understand how correlated the stocks are to the portfolio of stocks that we're using. We want to know that because, as you can see right here, we have technology, communications, financial stocks. So, for example, if I do technology, this would hypothetically be more correlated. And then, yeah. Again, this is just a time series visualization of stocks over time. Again, if it was technology, screw it, I'm just gonna run it. If it was a technology stock, the correlations would be higher, and also this time series map should hypothetically match much closer due to the fact that it's the same industry. So ta-da, you can see it very clearly. I mean, starting from 2020 during COVID, all the stocks dropped I'm guessing that's NVIDIA. Oh, that's not NVIDIA. That's very interesting. What is that? STU? Anyhow, you can see that this is way more red than the value stocks. Okay, moving on. We split into test sets, visualize test sets, visualize returns, geometric and arithmetic. There you go. Visualizations. We had a lot of these visualizations for the initial part of the paper, and we're all putting that together now. So now moving on to our Monte Carlo simulation and getting these risk metrics that we are going to use and explain with our rebalancing tool. This is the same code we used before. This is nothing interesting, but since my prior update, I did add at point of simulation calculations of these risk metrics. So Sharpe ratio, like before, of course, in order to do that, we calculate returns and volatility, and we get the Sharpe ratio by dividing returns by volatility. But now we're also doing Sortino ratio at point of simulation, max drawdown, Kalman ratio. I also added value at risk with 95 degree of given 95 degree of confidence level, conditional value at risk, and worst conditional value at risk. And also omega ratio. So all of these are all fit into all this one data frame, which we're going at analyzing with visualizations in multiple ways. So this is the old efficient frontier that you've already seen. I don't think this is for that exact. Yeah, I haven't run this. So this is for the value stocks. So as you can see, this is our maximum maximum risk portfolio. This is our minimum risk portfolio. And then more visualizations of portfolio weight allocations given the max. I believe this is the minimum risk adjusted portfolio. And we forgot to add the maximum risk portfolio. I will write that down and fix that. My apologies. That was my that was my mistake. Here I apologize. We've been working on this async for the last couple of days, and stuff moved around. I didn't expect this to occur. This is I'm not sure what this is. I think maybe I was just playing around. I think this is leading me into attempting to optimize portfolio via the Sharpe ratio. I think I was playing around with the scikit optimize package because I wanted to optimize portfolio using different metrics. I don't know why I did the Sharpe ratio here. I have no idea because we already have the efficient frontier. Right. Okay. This doesn't make sense. I don't know why this is here. I'm so sorry. Yeah, that's very weird. Right. So CVAR objective is this is us attempting to find the lowest conditional value at risk portfolio over time. Here, and then we're also doing optimization purely based on Sortino objective, solely based on Sortino calculation, and then yeah. So this is an interesting one because most of the time, conditional value at risk, mean conditional value at risk, points us to using one or two stocks. In this case, I think this is an old test. This literally just told us to invest all of our money in Pfizer, which is rather interesting, but did have a pretty high expected annual return. And then for Sortino ratio, it's a little bit more spread out. And then for columnar ratio, they're the same thing. And the same thing for omega ratio, and we got numbers here as well. And then this was my attempt at optimizing portfolio with everything. So we wanted to see if we can optimize portfolio based on best values of Sharp, Sortino, Colmar, Omega, conditional value at risk, and value at risk. And here we specifically used we used a scikit optimize package using SQP method. We used minimize because all of these we want to minimize. So essentially this we're going to report some of the values for that, and it was interesting because it did give us the highest return over everything we attempted to calculate. The one thing that is interesting here is that, to point out, this does not use this is a pure backtest solution, so it doesn't use simulation, but we just wanted to compare how this differs. And again, this is going into further backtesting where we are actually assigning a value and simulating how much money we could make given the different portfolio allocations we have. So as you can see, by using minimum risk adjusted return from our simulated efficient portfolio, frontier minimum risk portfolio, we would end up with $12,000 out of invested. We would make $285.45, and with a maximum risk portfolio, we would have made $21.80. And then we compare with equal weight, which is one equal weight portfolio, which is one of our questions in the research, and this goes on for everything, all of the calculations we're attempting to convey. So that is, majority of it is that. Now we're just putting stuff on paper and we're documenting the different tendencies each of these portfolio baskets have, given all of the tools that we have completed. So yeah, I'm very excited for you to read our draft, and I apologize for the delay on this. It's been a relatively wild time for all of us, and thank you for the short extension. Thank you very much for listening, and hope you have a great rest of your night.